Well, David talked at the beginning about the challenge of dealing with climate change and the scale of what we need to achieve there. And that's something of which I became strongly convinced about 15 years ago, and am passionately of the belief that we have got to build low-carbon economies, achieving those sort of reductions in emissions which David set out on those charts. And Paris was a step forward, but those charts which David showed illustrate the sheer massive scale of what we have to achieve. Because I was fascinated by the climate change challenge, that's why I agreed to become, back in 2008, the first chair of the UK Climate Change Committee. And I did that in parallel with being chair of the Financial Services Authority for 4 years, hoping that there would be a point at which the financial crisis would clearly come to an end and I could concentrate on climate change. But eventually I realized that financial crises and problems are never going to end and I had to give up the climate change job instead. But I've recently become chair of something called the Energy Transition Commission, which is a combination of some NGOs and companies, both from the incumbent fossil fuel side of business and the new entrant side of the business, really trying to work out how do we build a low-carbon economy, focusing primarily on the energy side, not on the land use side, which David also showed was important. How do we actually dramatically reduce the carbon intensity of our energy while, and we do need to do this, in many countries, in Africa and India, actually delivering far more energy than they have at the moment because they will need that to grow prosperity. And as I've come back to the details of climate change, having been away for it for 4 years, what I become aware of is something which is incredibly optimistic. And it was in, again, the charts that David showed, that since we first did the work on the Climate Change Committee in 2008, there has been a cost collapse, and a cost collapse that we did not then anticipate in the cost of some crucial technologies, in particular renewable electricity technologies, with the cost of wind down something like 50 or 60% since 2008, solar PV down something like 80% since 2008, lithium-ion batteries coming down dramatically. We are now seeing around the world auctions for electricity supply which are producing some absolutely stunningly low cost. In Chile recently, we have seen people winning cost auctions to provide wind energy at as low as $40 per megawatt hour delivered, 4 cents per kilowatt hour. Solar at 2.9, below 3 cents per kilowatt hour. We have seen offshore off the Netherlands, offshore wind at as low as 8 euro cents per kilowatt hour. The crucial issue that, of course, you then ask is, yes, but what are you going to do when the sun doesn't shine and the wind doesn't blow? It's all very well to say they can deliver these megawatt hours or kilowatt hours of electricity, but suppose it's not what I wanted. It's going to be surplus at some times of the day or year, and I'm not going to have it at others. So one of the things that we have been doing on the Energy Transition Commission is really doing a deep dive to say, well, can you deal with the problems of intermittency at a reasonable cost? And again, what has struck me from the results of what we've done so far is a remarkable piece of good news. We are convinced that you can build, or will be able to build within the next 20 years, something like wholly renewable systems, 80 or 90 intermittent renewable systems, even if you don't have a significant base load of nuclear as well, at a clearly sustainable cost in terms of the total cost, and that you can do that even if you use a rather blunt approach, which doesn't include, and I'll come back to smart meters, but does not include demand management. The way you do the analysis is to say, let me establish what is the maximum cost of dealing with intermittency. The maximum cost if I only had 2 technologies available. If I only had lithium-ion batteries and gas turbines to run a small part of the year. If you assume that those are the only 2 options available, it's actually quite straightforward to work out what the cost of backup is, because you simply have to work out how many kilowatt hours you have to shift around the year and how much you have to shift around, how much you've got to shift around half hour versus half hour when the wind suddenly slows down or clouds go across the solar PV, how much have you got to shift from night to day, how much have you got to shift a few days, how much have you got to shift a few weeks. You can work out that, you can model that. And then you've got to work out what do you think the cost of shifting with lithium-ion batteries is. And there's only a small set of parameters you need to know. You need to know the cost per kilowatt hour stored, and you need to know the number of cycles that a battery can run through over its life. And on gas turbines, you simply need to know what is the capital cost of a gas turbine and how much is that going to cost you across the year if you're only using it for a short period of time. We are now absolutely convinced that given the cost trends that are occurring, we will be able by 2035 in many places in the world to provide electricity at as low as $70 per megawatt hour, 7 cents per kilowatt hour, with the full cost of backup and intermittency dealt with systems which are 80 or 90% renewable. And I had no idea in 2008 that that was on the cards, that we would be able to say that with the confidence that we believe we can. I think we are looking at a real revolution in the ability to provide a renewable-based electricity system throughout the world, which is hugely important. Just by the way, it's not the whole of the decarbonization strategy, because you've got to work out what are you going to do with the things that you can't electrify or you can't electrify easily, like cement manufacture, like steel manufacture. There's a lot of other things you need to do. But the electrification story, the decarbonization of electrification story, is, I believe, an area where we should now be much more optimistic than we were 5 or 10 years ago, that this is doable, and doable at, I think, way below the cost that Nick Stern, in his report, suggested. As we decarbonize that power, we should electrify more functions in the economy. And there are many functions which we can take out of the fossil fuel domain and put into the electricity domain. One of the clear ones which I think is going to occur is cars, light vehicles. The way to think about an electric car and a petrol engine is that one has a fantastic engine but a rather heavy storage device, and the other has, frankly, an awful engine attached to a very good storage device. Electric engines are fantastically more attractive than internal combustion engines because they basically do what you want them to do. When you run an electric vehicle, 95% of the power coming out of your battery is actually turning into kinetic energy to take the car forward, and only 5% or so is going in waste heat. When you go around with an internal combustion engine, you are only getting 20 to 25% of the energy coming out of that petrol turning into kinetic energy, and the rest of the 75% is going into heat. And anybody who cycles around London in summer and goes alongside all these cars and buses and taxis churning out heat immediately understands that phenomenon. Unfortunately, when you look then at the storage efficiency, a litre of petrol, something like a kilogram, produces about 9.7 kilowatt hours of energy, and a kilogram of battery probably at the moment only produces about 0.4 of a kilowatt hour of energy. So when you get to the storage side, we've got a sort of 20 to 1 benefit on the favor of the petrol engine. But the costs of batteries are coming down, the weight of batteries are coming down. They will never be as efficient a storage device as a liquid hydrocarbon, but I think they will become sufficiently efficient that within 5 or 10 years, I think electric cars are going to be subsidy-free, competitive with internal combustion engines. And I think we are going to go down a route there where we will both decarbonize the car fleet and also get, alongside that, huge co-benefits of better air quality, lower noise pollution, as well as air quality pollution. I think that is simply something that is going to happen. There are also many functions within buildings, heat, which can be electrified. It can be electrified in the incredibly efficient fashion when you use a heat pump, which always sounds rather magic. You put in a kilowatt hour of electricity and you get out 3 kilowatt hours of heat. But it's very simple to understand. It's just sort of turning your fridge the other way round and getting the heat at the back of it, or taking an air conditioner and switching it the other way round through the wall is how that works. We believe that at very least 15 to 30% of all the fossil fuels now used in transport and buildings can be replaced by electricity within the next 20 years, and more beyond that. And I think I'm going to increase that estimate now that I've seen this amazing aviation development, because in the assumptions we're making at the moment, we've been conservatively assuming that we can't electrify any elements of aviation, but I think we probably can. We are going to decarbonize power, and then we're going to electrify more functions. And I think steadily over the 21st century, we are going to electrify more and more functions within our economy. I think in a sense, we are on the verge of whatever it is, a fourth or fifth industrial revolution, at the core of which is both the digitalization, data management, but also electrification. And I think it is a hugely beneficial and a hugely exciting set of opportunities. And we could do that even if the way that we were dealing with intermittency was with this blunt instrument of saying, well, I know I've got two technologies available. I've got gas turbines and lithium-ion batteries, and I just use that. But that would be a crazy thing to do, because although even if those were the only two options, the costs would still be manageable. The costs can be made much lower yet. They can be made much lower yet because of storage devices which are not lithium-ion batteries or gas turbines. And again, David talked about one of those, the hydropower. I hadn't actually seen that one before. I've been trying to work out whether I could do this in my own house, whether I could have a large tank up to which I pumped water during my solar PVs and then ran it down at night. But I don't know whether it makes any sense at a sort of retail rather than mass level. But there are a huge range of storage technologies, essentially taking water up to create an energy source, compressed air, all sorts of things. But there is also, of course, demand management. And what the smart meters are about is about unleashing the potential for demand management. In an environment where we are going to electrify more and more functions within our economy, we've got to start being much more sensible about our use of electricity by time of day and by when the supply is available. Because broadly speaking, most of us at the moment, except for a relatively small number of very, very heavy industrial users, essentially consume electricity the moment we want it without a thought for whether we are imposing a cost or not imposing a cost on the system. But we have systems where the marginal cost of production of electricity at many times of the day is essentially zero, and where using another unit would not impose another unit of cost. And we have other areas where if we all use electricity at that time, we are going to have to add very significantly to the cost of the system to create peak capacity. And we don't need to do that. If you think about your home, you have lots and lots of opportunities to shift that demand during the course of the day. A refrigerator with a smart bit of control technology could easily say, I don't need to be using electricity now. I'll use it in half an hour's time or 45 minutes time or 2 hours time. And it would not make an important difference to the temperature in the freezer or the fridge. Water heating can be shifted by many hours. Space heating can be shifted. Air conditioning can be heated. There's some others which are more difficult to heat, like cooking. You sort of have to do the cooking when you want, but washing machines can be shifted. And at the moment, we have almost no price signals encouraging people to be sensible, and no price signals that enable people to do something which is good for the macroeconomy, good for the climate, and good for them, which could actually reduce their cost of energy. These opportunities will become hugely more important with electrical vehicles. One of the things to realize about electrical vehicles is that if we do not do sensible demand management and sensible pricing by time of day or by time of supply of our electricity supply, electrical vehicles could make our management of intermittency worse. If everybody has an electric vehicle and decides that when they're going to plug it in is between 6 and 8 o'clock on a winter evening, they are going to make our problems of backup worse. But if we have an intelligent approach to deploying electrical vehicles, which say, you're not going to use that electrical vehicle again till tomorrow morning, please recharge it between 12 o'clock at night and 5 o'clock in the morning, and here's a tariff and a mechanism and a control mechanism that incentivizes you to do it and enables you to do it, then the fact that we are going to have this huge amount of lithium-ion storage capacity in the system on a distributed basis as a byproduct of people buying electrical vehicles, then we can turn that into a huge opportunity. So the whole area of demand management is an enormous economic opportunity. There is a much greater opportunity which will be important in the industrial space to encourage yet more use of a time of day or even time of year pricing of electricity. For instance, as we try to decarbonize the manufacture of steel and move to electric arc furnaces rather than blast furnaces, it may well then make sense to have capacity which is not used all of the time, but is used when we have surplus electricity. And electric arc furnaces could be one of the mechanisms which is helping us deal with some of the big seasonal shifts. But in the residential space, the smart meter is the most crucial technology. With smart meters, we could have certainly time of day tariffs, which encourages you to switch on your washing machine or to switch on your electric car recharging in the middle of the night. But we can also, over time, go to real-time charging, which actually says we're going to charge you more if you use electricity right at the peak, but we're also going to provide you with the facility to not do that by switching off your fridge or switching off something else where that you can shift it. Also, of course, smart meters will provide a set of other benefits. We all know the great management phrase that what gets measured gets managed. I don't yet have a proper smart meter in my house, but I do have one of those little things which tells me how many kilowatts of power are being used at any one moment. And I can tell you that this has produced a definite effect on my behavior. The extent to which I say, what on earth is that light doing on in this unused room? Where are exactly we are using electricity? The fact is, most people, electricity is a non-trivial part of their expenditure, but they have very little understanding of when they're doing it, what bits of their appliances are generating it, and the simple information flow will change behavior. I therefore think that smart meter rollout is absolutely essential to enable us to reduce still further the costs of a decarbonized electricity supply system, which is going to happen in any case, but we want it as cheap as possible. We want it as cheap as possible for society, and we want it as cheap as possible for individuals. I have to say my own preference then would be to just get on with it and get it into every home as quickly as possible. I know that we are essentially going down a sort of voluntarist route. Do you want a smart meter? But given that we're not going to charge people the capital cost of these smart meters, it's not clear to me that anybody would be disadvantaged by being told you're having a smart meter, whether you like it or not. You can then decide whether you use the facility of it to reduce your cost. I believe that there are some concerns that this is the sort of spy in your basement, which is going to reveal on WikiLeaks when you had your kettle on, and other dangerous things like that, and that this is what has pushed the government towards a voluntarist approach. But if we are going to do a voluntarist approach, I think we should actually try and make sure that the inertia is the assumption that you will take it unless you say you don't want it. Now, I was also at one stage chairman of the Pension Commission, and we created the idea of auto-enrollment into pension contributions. And again, we dealt with this problem of the balance between voluntarism and compulsion by saying, here is something which bluntly is good for you. You still have the option, if you want, to do something which is bad for you, which is not to contribute to a pension or not to take a smart meter. But let's try and get that as the inertia as much as possible, being to install these. Once we have installed the smart meter, there are then lots of other opportunities, and opportunities, I think, for small businesses, to go back to the debate earlier. Because the smart meter is a capability in itself, but it becomes powerful when we attach to it a set of tariffs which provide an incentive for people to move their demand by time of day. It becomes powerful when people come along and say, but now I can provide you actual management devices that directly link your smart meter to your fridge, to your washing machine, etc., and help you manage when you switch those on and switch those off, including switching them on or switching them off in the middle of the night. And I suspect that what we will head towards is that there is a basic capability, the smart meter itself, which is inevitably largely put in place and at the cost of quite big businesses, the basic utility providers of the distribution of electricity. But there is a proliferation of innovative small business opportunities about how you actually utilize and get the benefit of that within the home. So my feeling is that this smart meter opportunity is yet another technology which can help us drive still further down the cost of decarbonizing our electricity supply and increasingly electrifying our economy. I think it's very exciting, and I think we should get on with it as fast as we possibly can. Thank you very much.